Knowledge representation is a part of artificial intelligence which concerned with the AI agent thinking and how this thinking contribute to the intelligent behavior. These agents can represent the word with some formal representation and act intelligently. Whatever he is perceiving in the current situation, make it in the sentence format and pass it as an argument to the tell functions. Hello everyone, welcome to the one more session on artificial intelligence and applications for 6th semester B.Ca student. Myself Induje, faculty of Computer Science Department, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. In this session, we are going to discuss Unit 3, that is Knowledge Representation. As we have seen in the first session, we have discussed Unit 1. In that, we have discussed what is artificial intelligence, introduction about artificial intelligence, who is the agent works on what all environment, what all the different types of environment we have, and what is a piece description, that is a performance, environment, actuators and sensors description, how we can describe the environment with is the P representation or piece specification. In Unit 2, we have discussed about the problem solving techniques, what all the different problem solving techniques we have, like informed search, uninformed search, different algorithm in uninformed search and different algorithm in informed search. What a informed search means, you have some information, prior information before going into the searching. We have a DFS, BFS and different variation of DFS. When it comes to the informed search, we have a greedy search, A star search and AO star search. Now, what the knowledge or the information we are providing in the information search, how we are providing that particular knowledge, we are going to discuss in this unit, that is Unit 3. In Unit 3, we are going to discuss what is knowledge base, what is knowledge base agent, how we are going to represent the knowledge base, and how the agent is going to work with that particular knowledge base. So, let us start today's session. So what is knowledge representation? How we are going to represent the knowledge? Knowledge representation. Knowledge representation is a part of artificial intelligence which concerned with the AI agent thinking and how this thinking contribute to the intelligent behavior. Whatever the knowledge or the information is stored in the knowledge base, depending on that, who is the AI agent is going to act intelligently depending on the information what we have provided in the knowledge base. So that is a knowledge representation. It stores the information about the real world. What it stores? Just it stores the information about the real world, what is going on at the current scenario, so that the computer can understand and can utilize the knowledge to solve the complex real world problem. Why we have to store that? To solve the complex real world problem. But the point is that you can ask, when in database also we are storing, what is the difference between that database and in the knowledge representation, right? So here it comes. Knowledge representation is not just storing the data into some random database, but it also enables the intelligent machine to learn from that particular knowledge. So that is the difference lies between the database and then the knowledge representation. It allows the machine to learn from the knowledge or from the previous experience what it has, whatever it perceiving, whatever it is seeing in the current scenario, it understand, it will check with the knowledge base or knowledge representation and act according to that. That is our knowledge representation. Now coming to the knowledge representation or knowledge base agent. Who is a knowledge base agent? We know who is the agent. The person who works on particular environment, we refer it as an agent. Agent can be any sensors or any devices, anything like maybe. So though that particular scenario in that particular environment, whoever works, he is called as an agent. How this agent is making use of this knowledge base, that is called as knowledge based agent. Okay, agent who have ability or capability of maintaining the internal state of the knowledge, reason over that particular knowledge. Okay, we have a knowledge, agent should be able to reason over that particular knowledge and update their knowledge after observation and take the action. Who is a knowledge based agent? Agent who knows, have some internal state of knowledge. He can reason over that particular knowledge and he can update the knowledge according to the environment or the observation what he has done in that particular environment. These agents can represent the world with some formal representation and act intelligently. Like for example, we have discussed switching on the AC. Whenever someone enter into the room, we have to make the sensors such that whenever someone enter into the room from the higher degree temperature, it should switch on the AC. That is a knowledge and the perception what the machine has, that is a sensors has, right? So that is what it solves some formal representation and act intelligently. Who act intelligently? Knowledge based agent will act intelligently. Depending on what? Depending on the knowledge base whatever he has previously. So knowledge based agent can composed of two main parts. What are the two main parts? Knowledge based agent should have a knowledge base first, right? And then he should have an inference system. We'll see what is a knowledge base and then the inference system. What is a knowledge base? As we have seen already, what is a knowledge, how we are going to represent the knowledge. What is a knowledge base? Knowledge base is a central component of the knowledge base agent. Without the knowledge base agent does not exist. Okay, is known as a KB. What is known as KB? Knowledge base is known as KB. It is a collection of the sentences. Sentences means perceptions what it has done or the previous experience what we have given to the computer or the system. It is a collection of sentences. The knowledge base of the knowledge base agent stores the fact about the word. Depending on what? Depending on the perceptions what is going to do. Knowledge base is a required for updating the knowledge from an agent to learn with the experience and take action for knowledge. Why we need the knowledge base? Because knowledge base agent will learn from that particular knowledge base. That's why it's an essential component for the knowledge base agent. That's why we call it as a central component. It is a central component of knowledge base agent. Without knowledge base agent cannot act intelligently. That's why it is very important. After knowledge base, what is the second part we have? We have an inference system. What is inference system? Inference system is inference means deriving a new sentences from the old sentence. Whatever the sentences present in the knowledge base, using those sentences we are deriving a new sentences. Okay, that is called as inference system. Inferring, we are interpreting the sentences. Okay. Inference system applies the logical rule. How we are going to provide the inference to the knowledge base? By using the logical rules to the knowledge base and deduce a new information. We can form the new information by applying the logical rules. Inference system generates the new fact so that the agent can update the knowledge base. Whatever the knowledge base we have already provided, upon that particular knowledge, using an inference system, what knowledge base agent will do? It will add up the knowledge upon that as a stack. Okay, it will add up the stack of knowledge by using the inference system with the help of logical rules. So there are two main rules how we are going to provide the inference system. One is forward chaining and one is backward chaining. Forward chaining and backward chaining will be the last topic of your this module. We'll discuss in further sessions. Okay, now concentrate on inference system. There are two main parts in the knowledge base agent, that is knowledge base and then the inference system. We have discussed what is a knowledge base and how the inference works with the knowledge base. Next, architecture of the knowledge base agent. What is the architecture we have? How exactly knowledge base agent works? What we have seen here, it will take the perception or it will sense the environment. Knowledge base agent take the input from the environment in the perceiving. the environment, what all going on in and around the agent. It will perceive all the information and it will give it as an information that that information is given as an input to the inference engine. What inference engine will do? Inference engine will infer that particular percepts into the sentences with the help of what? With the help of knowledge base. It's combination of prior knowledge base and then the whatever the observation it has done from the environment. Using both, it will provide a new sentences. Who will provide the new sentences? Inference engine will provide the new sentences. When it is provided with the new sentences, that can give it as an output and can be stored into the knowledge base by updating the knowledge base for further learning. That is what described here. Knowledge base agent takes the input from the environment as a perceptions. The input is taken by the inference engine to the agent and which also communicate with the KB. That inference, whatever we have taken, that will be taken by the inference engine and also communicate with the knowledge base to decide as per the knowledge stored in the knowledge base. Then the learning element of the knowledge base agent regularly updates the KB. The learning element will regularly update the KB. Whatever updation, whatever the inference has been done, that will be updated to the knowledge base. This is the architecture of knowledge base agent. How exactly knowledge base agent is gonna work. Knowledge base agent must be able to do the following. Knowledge base agent must do the following. What is that? Knowledge base agent should be able to represent the states, action and etc. What is the current state is working in and what all the action he can take according to the situation. He should be able to decide that, or should be able to represent the states and then the action what is gonna take. And he should be able to incorporate the new perception in each and every, in the real world or the real time, each and every minute the scenario will be changing, right? So he should be able to incorporate the new perceptions, what is going on in and around, what is in that particular environment, what is new happening, what is the thing that is changed from 1 minute to the second minute. That all perception he can incorporate into the knowledge base, and he can able to update the internal representation of the word. As when he is incorporating the new perception, he has to update his internal representation. What is the internal representation? The knowledge, the learning. He has to update that knowledge base. And the agent can deduce the internal representation of the word. Once it is updating, he has to make the sentences. He has to deduce the sentences using the inference engine, forms the new sentences to store it in the knowledge base. The agent can deduce the appropriate action. He can take the action depending on what the inference has been done from the internal representation, and using the knowledge base he is able to take the new action which is already not stored in the KB, knowledge base. So these are all the must thing what the knowledge base agent should do. The following are the 3 operations which are performed by the knowledge base agent in order to show the intelligent behavior. We have 3 levels in order to show the intelligent behavior. What exactly operations he can do, knowledge base agent can do? First, he should tell. What it should tell? What is going in and around the agent? He should tell it. He should perceive it. Okay, that is, tell the knowledge base what the perceives from the environment. What exactly the agent is perceiving from the environment, he should tell that. Once it is told, he should ask the knowledge base anything similar to this perception you have in your knowledge base. You should ask the knowledge base something similar from the previous experience, it is there. So ask the knowledge base what action to be performed in this particular scenario. Once it asks the knowledge base, some actions will be stored for that particular scenario and it has to perform that action. What is the first thing the agent should do? He should tell what is going in and around in the environment. After telling that, he should ask the knowledge base whether the scenario and this action is present in the previous knowledge base or in the stored knowledge base. If it is there, he should take the appropriate action, that is performance. He should perform. Tell, ask and perform are the three major operations what the knowledge base agent can do. So the same thing can be represented in the pseudocode format. Right, the following is a structure outline for the generic knowledge base agent program. That is a pseudocode what we are writing. First, we are creating one function, that is knowledge base agent. What we are passing is here as a parameter the perception, what the perception is observing in the environment, that is passed as a parameter here. Then persistent, we are taking one variable. In that variable, what all we are providing? We are providing the knowledge base and a current knowledge base and the previous knowledge base. And a counter, we are taking and initializing that counter to the value 0, indicating how much time it will take to take the action on that particular scenario. Then what is the first action he should do? First action the agent should do, that is tell action. So we have to call the function tell. In that tell, what I'm giving? I'm giving the knowledge base which is already there with us, and then make the perception in the sentences. Whatever he is percepting in the current situation, make it in the sentence format and pass it as an argument to the tell functions. Once it is telling to the knowledge base, and again it is taking the action. What is the action after telling? We have to ask whether this scenario, the similar scenario is present in the previous knowledge base. So we are asking, we are calling the function ask with the knowledge base and the make action. What is next? We have to take the action, that is what is the action for that particular knowledge base, and we have to pass it as a parameter again. After that, after tell, after ask, what we have to do? We have to perform. How we are going to perform? KB, make action. We have to make the action of this sentence. What is a sentence said by the tell function, and we have to make the action. And whatever the action is there, that should be performed, and increment that has to be stored back to the knowledge base again. What action you have taken, that action has to be stored back to the knowledge base. That is, we are returning the action here. So this is a pseudo code for 3 operation what knowledge base has to do. Next, we have a different levels in the knowledge base agent. What are the different level the knowledge base agent works on? First is a knowledge level, logical level and implementation level. As we are telling that tell, ask and perform. That is, telling is a knowledge level, ask is a logical level and perform is again a implementation level. So let us see what is knowledge level. Knowledge level is the first level of knowledge base agent. Need to specify what agent knows and what the agent goal are. What you know and what you are trying to up to, that must be known by the knowledge level. But when you are in the knowledge level, this is a basic requirement what you should have. Agent should know what exactly the information he has and what exactly the information he has to retrieve. Then for example, suppose the automated taxi agents need to go from station A to the station B and he knows the way from A to B. So this comes in the knowledge level where the taxi driver has his knowledge how to go. So that is a knowledge level. We need not to do much. We need not to make the machine learn because it is already present. The learning is already present in the knowledge base. It will just make use of that particular knowledge base and it will move in that particular direction and takes the action. That is a knowledge level. When it comes to the logical level, what is the second level? Logical level. Understand that how the knowledge representation of the knowledge is stored. How exactly the knowledge is stored, in which logic, in which proposition we have implemented that knowledge. That is understood by the logical level. At this level, the sentences are encoded into different logic. How? By implementing the logical rules, all the sentences are encoded into different logics. All the logical levels can be expected to the automatic agents are reached to the destination. At the logical level, we can expect the automated taxi agent to reach to the destination B. We can expect that, but how, we don't know. We'll be having 3 or 4 routes. Which route we have to supposed to take? It will show all the 3 routes to from A to B. From the source destination A to B, we have a 3 routes, right? It will show all the 3 routes. In the first scenario, in the first level, that is knowledge level, here the agent knows, if I want to go this route, if I go in this route, I can reach to the destination. Now in the logical level, have all the different routes to reach from node A to destination B. So what comes with the implementation level? That is a performance. Whatever the logic we have a 3 routes, right? From A to B, we have a 3 routes. Which route is to be opted? It is done by the implementation level. This is a physical representation of logical and knowledge level. It has both logical and knowledge level. At the implementation level, the agent performs the action as per the knowledge and in the logic level. It makes use of both knowledge level as well as a logical level. Here, for example, what we have taken, automated taxi agent actually implement this knowledge and the logic so that he can reach to the destination. So here in this, he can check what is the minimum time, what is the minimum time to reach the goal B, or it can check for the traffic, where is a less traffic. He can opt that particular route where is a less traffic. See, this is a left traffic. If this is a minimum time, it combines both less traffic and it will have the minimum time. So it will choose this particular path. So that is the implementation level what we have for the knowledge based agent. Then approaches to design a knowledge based agent. How we can design a knowledge based agent? We have two approaches to design a knowledge based agent. One is a declarative approach and one is a procedural approach. We have already seen the example for this. Declarative means what we are telling? Tell, ask and perform. That is a declarative. And what we have wrote the pseudo code for tell, ask and then the perform, that is a procedural approach. In the declarative approach, what we are doing, we are initializing, we don't have anything in the starting. We are initializing the empty knowledge base, nothing is there, and then telling the agent all the sentences with which we want to start with. We are just telling. We are storing it in the form of natural languages. That is called as declarative statement. We are declaring all the knowledge in the form of sentences. Fine, that is a declarative approach, how we can design the knowledge based agent. And second type of approach is a procedural approach. We supposed to write a proper code for this thing, that is a programming code, that is called as procedural code. We directly encode the desired behavior as a programming code. What we are doing? We are encoding in the form of programming code. That's what we have seen, the pseudo code for tell, ask and then the perform. That is a procedural approach example, which means that we just need to write the program that already encodes the desired behavior of the agent. In the real world, a successful agent can be built by the combination of both declarative as well as a procedural approach. Some of the sentences is given using the declarative approach and some of the knowledge is given using the programming in the form of programming code. If we use both, we can develop the very successful knowledge based agent. Okay. Next, what we have is logical representation. We have seen why logical representation is used in the logical level, how we are going to represent this knowledge or the sentences in the logical representation. One of the technique of knowledge-based representation. Logical representation is one of the technique to represent the knowledge. It's a language with some concrete rule which deals with the perceptions and has a no ambiguity in the representation. It deals with what? It deals with the preposition. How logical representation will be done? Using the prepositional method, and whenever we are representing the knowledge in the form of logical representation, there should not be the ambiguity. What do you mean by ambiguity? There should not be any confusion between the sentences what we are providing or the knowledge what we are providing. For example, you can say it is sunny, it is raining. These both are the contradictory statements, right? Either it should be sunny or it should be raining. So such type of ambiguity should not be there when we are representing the knowledge in the form of logical representation. Okay, then it consists of perceivably define the syntax, precisely define syntax, and then the semantic. It consists, knowledge representation consists of what? Precisely defined syntax. We should follow the particular syntax when we are representing the knowledge in the logical representation, and follow some semantics, make it understandable. So it has a precisely defined syntax and semantics which supports a sound inference, which support the inference systems what we have discussed already. Each sentence can be translated into the logics using the syntax and semantics. Whatever the sentences, we have a declarative statements or the declarative approaches that can be converted into the logical symbols using the syntax and the semantics of logical representation, where the syntax is well-formed sentences in the language and the semantics defines the truth or the meaning of the sentences. What is a syntax with respect to the knowledge base? It is a well-formed sentence. And what is semantic? Whether that sentence is true or false, that represent the semantics. For example, I can say it is raining. Well-formed sentence, we have represented it properly. The semantic is what? Yes, it is true or it is false. Only that much we should know in the logical representation. Either it should be 0 or 1, true or false. We can represent the logical representation in two techniques. One is prepositional logic and first order prediction logic. What is prepositional logic and what is first order prediction logic? Let us see what is prepositional logic. Prepositional logic is very simple logic. We have a sentence. For that particular sentence, we have only two things, whether the sentence is true or sentence is false. That much. That is a prepositional logic. It don't need to think much. Maybe is not there. True or false, maybe, later, something like that sentences will not come in the prepositional logic. When it's come to the first order logic, it can predict. The first order logic can predict. It may happen. Like what is the weather tomorrow? Maybe raining. That comes to the first order logic. Now what is currently going on? It is sunny. So that is a prepositional logic. Hope you understood the difference between the first order logic and then the prepositional logic. Where the prepositional logic does not think much. It just gives the current answer, yes or no. Where the first order prediction logic, as the name itself indicates, it try to predict what may happen. Okay, prepositional is a declarative statement which is either true or false. So we have discussed what is declarative statement, whether the statement should be true or either it should be false. We cannot combine both. It cannot predict, it cannot assume, and prepositional logic is also called as Boolean logic. Why? It works with the values 0s and 1. If it is a 0 true, 1 it is a false. Like that it will works on 0s, 1 it is called as prepositional Boolean logic also. Prepositional logic consists of the objects, relations or the functions and the logical connection. It will be having some object and what is the relation to that object with the real world, and how they are connected using some logic, how objects are connected to each other, with what logic it is connected. That will be represented in the prepositional logic. These connectivities are also called as logical operations. How we are providing the connection, that is called as logical operations. Example for the prepositional logic or the prepositional sentence, it is Sunday. Yes, it is Sunday. Today is not Sunday, right? So it will be false. It giving, this is a sentence syntax and this is giving semantic, right? Semantic for that particular syntax. The sun rises from the west. It is true? No, it is false preposition. So 3 plus 3 is 7. Again, it is a false preposition. 5 is a prime number. Yes, of course, all of us know 5 is a prime number. So it gives the value as true. So this is a true preposition. So this is some example for the prepositional logic. When it comes to the prepositional logic, we have two types of sentences. One is atomic preposition and one is compound preposition. Whatever the sentences we are representing in a single statement, a single sentence, is called as an atomic preposition. It consists of the single prepositional symbol and a single sentences we are representing. As in the previous example, we have seen here, this is Sunday, single sentence is there. So this can be the preposition, atomic preposition. There are the sentences which must be either true or false. It must be either true or false. Whatever the example we have seen, all comes with the atomic preposition. Example here also we have given 2 plus 2 is 4. Yes, a single true or false condition is there, so it is an atomic preposition as it is a true fact. Or the sun is cold, definitely not, sun is not cold, right? So it is a false preposition, false atomic preposition we can say. So another type of, what is the second type of preposition we have is compound preposition. As name itself indicate, it's a combination of atomic preposition or atomic sentence together, combining atomic sentences, we are forming the new sentence, that is called as compound preposition. The compound preposition are constructed by the combination of simple or atomic preposition. We are making use of atomic preposition and compounding together to form a new sentence or new preposition, that is called as a compound preposition, using a parenthesis and a logical connections. How we are connecting these two atomic? By using the logical connection or by using the parenthesis. What all the logical connections we have? And, or, not. These are all the logical connections we have. Depending on that, we are going to connect two different atomic sentences or atomic preposition to form a single compound preposition. Examples what we have is, it is raining today and street is wet. What the logical connection I am using? I am using and connection, right? And connection. It is raining today is a single atomic sentence. Street is wet is also a single atomic sentence. By combining two atomic sentences using the logical connection, I am forming the new sentences. That is, it is raining today and street is wet. But here condition again, it should be either true or false. Okay, both the sentences statements are true, so it will be true. Another example, Ankit is a doctor and he has his clinic in Mumbai. Right, the sentences should be true or the false. Here also we have a two atomic sentence. Ankit is a doctor, one atomic sentence, and he has his clinic in Mumbai. That is a second atomic. Combining together, we are forming the compound preposition. Next, what we have is prepositional logic. How we are giving the connection, logical connection. We are providing the connectivity using some of the logical connection. What are those logical connection? And, or, implies, if and only if, and not. These are all the logical connection which is used to give the compound preposition. And what all the symbols what we have used for and? We are using cap, and for or we are using opposite of cap, and for implies we are using arrow. If and only means we are using double arrow, and negation we are using not signature. So negation sign. Negation. So this is what we are giving. Forming A. A is one atomic sentence, B is one atomic sentence, and we are connecting both by using and or implies. If A is true, implies B is also true. If A is false, then B is true, like that, implies. So bidirectional, it will go if and only if. If A is true, then only the B is true. If A is true, A is false, then B is false. Like that sentences we can use. And if A is not true, right? So that is the table, summarized table for the prepositional logic. Next, what we have is limitation of prepositional logic. Why we have to go for the first order logic? So there are some limitations in the prepositional logic. So to overcome from that limitation, we have to go for the prepositional logic. First and the foremost limitation is that it cannot predict, right? As we have stated in the statement of preposition, it cannot predict. That is the first drawback what we have. We cannot represent the relational like all, some, none, or the other prepositions using the prepositional logic. So we cannot represent all will be true, and some of the sentences is true and none of the sentences is true. Like that we cannot represent in the prepositional logic. A prepositional logic has a limited expressive power. It cannot express whatever exactly it want to. It is limited in expression. So we are going for the first order prediction logic. In the prepositional logic, we cannot describe the sentence in terms of their properties and the logical relationship. We cannot describe in the terms of properties, what all properties the sentences can have. What is going in and around here is just not true and false. You have more than that. So represent such type of the real world scenario, we have to go for some other method, that is a first order logic method, that cannot be handled by the prepositional method, prepositional logic. That is the limitations what we have in the prepositional logic. So we have to move other technique to represent the knowledge base. So this is all for today's session. What is knowledge base? How we are going to represent the knowledge representation, who is a knowledge base agent, architecture of knowledge base agent, different levels of the knowledge base agent, how to create the knowledge base agent, declarative statement, and then the procedural statement, and then what is a logical representation. In the logical representation, again we have studied about the prepositional logic, how we are going to represent the knowledge with the help of prepositional logic. That's all for today's session. Thank you.